Sorry for the slow start, but we'll get through dictionaries here today. Dictionaries are just another data type. These are going to be like a list, so they're mutable. But unlike a dictionary, you have indexes, right? And remember, everything's ordered inside of there. Indexes for a dictionary can be a lot of different data types, not just integers. So we use integers for lists, 0, 1, 2, 3, 4, whatever. In a dictionary, we can use just about anything we want, other different data types. And so we call those keys. So in a dictionary, we call them a key, and we call whatever value is associated with that key a value. Therefore, we have a key value pair. So if you look at our dictionary down here, you are going to see that we have curly braces for a dictionary. Okay. You're going to have the key, which in this case is a string called size, and it has a value of fat. Notice you have a colon and you have fat. I can go a little bit bigger here if you need be. Okay. Then we have the next key, which is color and the value of gray, a key of disposition, and a value of loud. All right. And these two are paired up. You can notice with the colon and a space in there, this is how we make a key value pair. Right. So the benefit of this is these are unordered, meaning these values and pairs can be swapped all the way around in this list or in this dictionary. That part doesn't matter. When I want to find the size, I look for the key of size and I will get returned the value of fat. I look for the key of color, I get back gray. And if I look for the key of disposition, I get back loud. So this is basically a small database, but the benefit of doing it this way is you can be way more descriptive of your data in there and be able to set those key values all the way through there. Okay. So for example, for size, if I wanted to get size back, I would say my cat size, right? This would be in place of like putting a 0 in a list, right? We would put 0, that would give me back the first value that was inside the list. In this case, we want the size, and therefore it gives me back fat. And we can see that come back. And so we say if my cat has blah fur, we could say color, and it would plug in gray inside of here, and then concatenate this string all back together, right? You can still use integers as keys. You can use strings. You can use whatever you want. It just cannot be 0, all right? And they don't have to start at 0. It can be any number. So for example, 1, 2, 3, 4, 5 is the value of the luggage combination, right? And 42 is the answer in this case, in this one. Right? So unlike lists, items in a dictionary are unordered, meaning that the first item in the list of spam would be spam 0, right? Like cats. If I want the first one out of here, I just give it the name and therefore it would pull in. There is no first item in a dictionary. As a matter of fact, if you print it out twice, you will more than likely get it switched around when it gets printed out. There's no order to it whatsoever. The only thing that's there is your key and your value pair. That's all that matters. So if you want to sort it and do things like that, we got to do some extra magic on top of there to do that. All right. Just like here, if we say this one of cats, dogs, and moose, this one has dogs, moose, and cats. They're in different orders. These two do not equal one another, right? Spam 0 is cats, bacon 0 is dogs. These two are not the same list. Even though they're the same words, same values, they're not the same thing. In a dictionary, if you scramble them up like this, those are equal to one another. Does everybody get the whole order thing? Okay. Therefore, we cannot slice them because there is no order, right? We can't say 1 to 4 because there is no order to that. So if we want to pull values back, we ask for the key and what we want. If we do a key of color and there is no key up here called color, then we're going to get an error of key color. All right. We'll get this key error. Again, you could do this on a try and accept. You could accept on key errors if you needed to and get back that way. Okay. What's nice is you can organize this in very different ways, or the ways you want to go through. So if we do birthdays here, and I have Alice, the value is April 1st. Bob, the value is December 2nd. Carol, the value is March 4th. Then while true, enter in a name. Doesn't matter what name, right? We're going to store that. If name is equal to blank, we break out of this. Otherwise, if name is in birthdays, in which case by default, it's going to look at all the keys. So if I type in Bob and Bob is in the key here, then it's going to match this line here and we'll print out the birthday of that person. If that person is not in the list, we hit this else statement and say, I don't have birthday information for whoever. What is their birthday? We type it in. It will store that name and birthday inside this list or inside this dictionary. And it does that the same way you would in a list, only we say the birthdays, whatever name value we want to put, and then the birthday it's equal to. Anybody have any questions on this little app? So for example, if we type in Alice, Alice was in the dictionary. It looks up that and it says April 1st is the birthday of Alice. Give me another name. It looks up Eve. Eve was not in our dictionary. Therefore, it says I don't have that information. What is their birthday? And then it goes ahead and updates the quote database. Again, a dictionary is very similar to a database, but it's not a full-blown database. You guys are programmers, you know that databases work very much differently. But this allows us to have a quasi database within our system. Okay. Let's see here. Again, when you call a dictionary, for example, we have spam is equal to this dictionary, right? We have 3 different methods that are associated with a dictionary. Remember, there was a lot of methods associated with the list, right? We only have 3 with the dictionary. If we call dot values, it's going to give us back all the values in a list. And it's actually a list-like object called dict items, okay, or dict values in this case. And it's going to look a lot like a list. You'll end up with something that looks like this, right? So this one will give us keys. Dot keys pulls out color and age, puts them in a list-like object, and returns this back to us. So all we have to do is call spam.keys. We get all the keys back. If we leave off dot keys, it's the equivalent of doing dot keys. Meaning if I say spam, it's going to give me back all the keys for it, right? If we want to convert that to a list to actually do something with it, we need to say list spam keys. That will actually convert it to a true list. Note that this and this is the same thing. This overall thing makes it different. It's a totally different data type that comes back. So if you want to convert it, you just throw the word list in front, parentheses, throw it in the list function. It converts it out for you. Then you can do whatever you want with it. You can now sort it. You can now do whatever you want on that side. Okay. If you call dot items, this is going to give you back a tuple where the first part is going to be the key. The second part is going to be the value. And therefore, typically what we use there is called K comma V. So for K comma V in spam.items, note that K comma V is what? Does anybody remember how we did that last time? There was a special little trick we called that. It's literally called trick. The something something trick.
That was like
That's it. Multiple assignment trick. So what we're doing here is we're getting back this tuple, right? Color, red. The first value is color. The second value is red. And it's just going through this dictionary. Puts the key first and then the value. So we're going to use the letter K to represent the key, V to represent the value. And therefore, inside of this for loop, we can use those 2 variable names in order to print those out. So we could have K comma V, we could use key comma value. We could put whatever we want. We're just assigning a value to it so that it makes more sense to us. I could do A comma B, but that's not going to be as useful for you, right? Python's all about making sure you use useful variable names for yourself. All right. Does everybody understand dot keys, dot values, and dot items? Dot keys is going to get us back all the keys. Dot values gets us dot values. Dot items is going to return back a tuple of a key comma value. All right. We can check to see if something is in the dictionary or not. So if we say, name in spam.keys, we can get true. If we see if Zophie is in values, we can get true. And we can also check for in and not in, just like we did inside of a list. So if Zophie in spam.keys, do something else, right? We also have a couple other methods in order to retrieve something out of a dictionary. So if we have this thing called picnic items, right, where apples is 5, cups is 2, and we can say, I am bringing the string of picnic items dot get cups comma 0. What this does is it looks up cups. If cups has a value, it goes ahead and returns that value. If it doesn't have a value, we go ahead and put back 0. Does that make sense? So here's the one that you're looking up. It looks up here, says I've got cups. I have 2. Therefore, I'm going to return 2 back. If I didn't have 2 here, then it would go ahead and put 0 for me if cups didn't exist up above here. Does that make sense? So it's looking up cups. If cups exist, go ahead and give me back the value. If it doesn't exist, give me back 0 cups. Same way with eggs. I'm going to look up eggs. Eggs does not exist in here, right? Therefore, we say give me 0. So when it prints this out, it says there's 0 eggs in the dictionary. Does everybody get why we use .get? Basically, it says look this up. If it doesn't exist, give me back this value. That way I don't get an error, right? We can simply just say give me back 0 if it doesn't exist. We also have the option for like here, for example, if you wanted to just do string of picnic items eggs, you would get an error of key error, right? So the benefit of .get was it will look up this just like this and then return a value if it doesn't exist. We also have set default. What this is going to do is exactly the same thing as get, is look it up and return something. Only this time it says, if that doesn't exist, I want you to set it to this value. So for example, if color is not in spam, which we can see color is not here, we only have name and age, then we say spam color equals black, right? That would set that name and that color, and this dictionary would now have color black in there. Set default does this multiple step all in one whack, where I just say set default color black. It looks up color, doesn't exist. I'm now going to set color to black. And therefore, if I look up spam, I can see that color black is now in there. All right. So the difference between get and set default, get will look for a value, doesn't exist, give me something back. Set default says if it doesn't exist, set it to this. All right. Pretty printing. So Pretty Print is a module that you can import into your project. So for example, if we had this Python project here, we could import PP print at the top. Then you use Pretty Print, in which case you call it prettyprint.ppprint. Count, and then count is whatever dictionary. The idea is if you print a dictionary, it can look rather unorderly, something like this when we print it out on the screen. It's very hard to follow which one's the key value pairs here, right? If we use Pretty Print, it's going to actually print something that would look like this. So it's nice, clean, and ordered as it prints it out on the screen. Now here, it doesn't seem like a big deal, but if you have a really big dictionary of data, this puts it in a nice, clean order all the way down. So I can search down, look through the keys, I can pull the values, I can pull it all out. Much, much easier to read it. So if you guys get into some rather large dictionaries, which some of you will, use Pretty Print to print that out on the screen. What we can't do, though, is use that to print that out on our project, right? Just like we use a for loop for a list to print it out nicely, we're going to do the same thing with a dictionary. Use a for loop dot items, print it out nice and clean so that it would look something like this. We talked about our items up above. Here, this is the for loop we would use to print this out nice and clean. So we could print key colon something, value colon something, it would print it out. Now, obviously, I wouldn't use key and value. You might have some actual term for that. So whether it was name and age or whatever you decide to set this on all the way down. So a great way to think about dictionaries is a way to set attributes for a value. So if I have a dictionary named Jason, then in the attributes or in the dictionary, I could have I and then the actual color, or I could have height and set a color. Instead of before, when I had a list, I had to remember which spot that was in. Here, I can just call for a hair color and it pulls back the hair color. Something that's much more readable and understandable for you guys to pull back. Right. So dictionaries are used for a lot of real world things. For example, anybody play chess? Right. So chess, everything's based off a coordinate system. You have G5 going across here. If we want to create a chessboard, we can do that with our dictionary. So we could say 1H is set to the black king, 6C is set to the white queen, 2G is the bishop, black bishop, et cetera, et cetera. And that way we could take a dictionary and represent a chessboard. Now that would be nice because then we could tell it to print chessboard and we may be able to actually print this on the screen if we were using a third-party package to print that on the screen kind of thing, right? Same way with even a tic-tac-toe board. This one you guys can build pretty easily. So for example, we have top left, top middle, top right, middle left, middle, middle, middle right, right? We got this whole coordinate system set up. This is what the board would look like as a dictionary. So in this case, we put the top ones on this, then we put the mids, and then we put the lows. We could put this all in one long order, but it wouldn't make much sense for us, right? If we design it like this in our program, we can keep an idea. This is the top row, middle row, bottom row. All right. If we wanted to print that, in case here, notice that we put empty spaces. Therefore, when we print it to the screen, nothing prints, right? Just prints an empty hashtag basically going across there. When somebody was to pick first X's, right? They decide to go in the middle. Therefore, we would change mid M to X. That way, when we printed out the board, we would see the board that looks like this. And if we actually played a representative, it would look like this one. All right. So this is the actual print function to print that board. Essentially, it's going to print the top left, then a bracket, or in this case, a pipe symbol, right? Then we're going to print the middle one, a pipe symbol, the last one. And this is the tic-tac-toe board you would end up with if you did that. Real simple board. As I place a letter in there, then you're going to see those values actually print out to look something like this. Again, all you're doing is using one major dictionary called the board, and then you're storing those variables accordingly to use it in real life. So you could build a game like this for tic-tac-toe. You could build a game for Connect Four, right? Same concept. You build out a dictionary that looks like a Connect Four board, have them drop the little pieces in there. If you get 4 in a row, you can check and verify. So here we would have to write verification to see if there's all X's in top left, mid left, or lower left. If there's X's, X wins, right? If there's O's, then O wins. We would have to write functions to check this column, this column, this column, this row, this row, this row, this X, and this X. We'd have to write all those different checks to see who won. Okay. So here would be the code that looks like this. For turn equals X, aka X always goes first, right? For I in the range of 9, meaning we're only going to need 9 turns for tic-tac-toe, right? It's the max number of turns, and that's a what? There's a name for that, tic-tac-toe. Am I really that old? It's a cat's game, right? Yeah. Thank you. Thank you for that. I was really starting to feel old there for a second.
I have never heard that.
I've never heard that either.
Okay. Yeah.
Oh, he's older than you.
It's a cat's game when you have a tic-tac-toe where nobody wins. All right. So max is 9. Real nice guy, right?
Oh, nice.
When you get over here, it says turn is for whoever. What space should I move in? We're going to gather input from the user, in which case they would have to specifically type mid-R or top-R or low-R in order to make it work, right? They type it in. We now set the board to that move that they did. If the turn is X, we now flip it so that turn is 0. and this whole loop starts over again. This is all going to be in a while loop. Everybody got it? Or in this case, it's not a while loop. It's just a for loop that we're using it in. Same concept. This loop will then start over and you'll go back through here all over again. So it'll look like this on the board. We ask, hey, it's turn for X. What space do you want? We say mid M. Therefore, it puts an X in the middle. They play a game. It ends up looking something like this and go on. Now, obviously, it isn't complete because we have no way to check for who won, who lost, right? And that would be something that you guys could build out and go through there. If you did this for a midterm project, you would have to make it somewhat unique to yourself. Don't give me an actual complete tic-tac-toe program because, frankly, I can read this massive note just like you, and this is the result of what that tic-tac-toe program would look like. So let's go look at that code. Oops. There's a link there. I clicked on the wrong link. Okay. Scroll back here. All right. The last little concept for today is nested lists and dictionaries, meaning you can put dictionaries inside of dictionaries. You can put lists inside of dictionaries. There's all sorts of data types you can mix in between each other. So one good idea would be something like this where you have a picnic, right? These are all the guests is this overarching dictionary. Inside of that, we have a key of Alice, and Alice has his own or her own dictionary that is bringing apples and 5 of those and bringing 12 pretzels. Okay. Bob is bringing ham sandwiches of 3, apples 2. Carol cups 3, apple pies 1. So if we wrote a little function that did this, num broad equals 0 for k comma v, aka let's pull out this key and value. Let's print it out nice and clean. If that item exists, if it doesn't exist, put 0 in for that. And then we're going to do our number brought. Therefore, if we run a print for each one of these items, we can get a nice little output of things being brought. Apples are 7, cups is 3, cakes is 0, ham sandwiches 3, apple pies of 1. Everybody understand a little bit of dictionaries? Now, homework assignment 3, which is going to come up here a little later, we're going to be hammering dictionaries and kind of doing examples there. So I'm not going to go too in depth with a bunch of coding examples or things like that unless you guys want to, but we're going to be hammering that in homework 3.
So that's where we'll actually.
That's where you'll get the hands-on with dictionaries and start coding. Yep. You guys will be taking a database of the Ford inventory of cars. You guys are going to have to do a bunch of things to sort that inventory, pull out different keys of cars, sort things out, that kind of stuff. You'll see that in the homework assignment when we get there. For now, you just need to be able to go play with dictionaries and lists, understand when you would use one or the other, right? So what would be a good example of using a list? A what? A grocery list. Yeah. Yeah, you could do a grocery list. In a grocery list, you could put all the items of those groceries, right? So let's do something like this just to give an example. This is a good example because we can actually show you the difference between the two. So,
Make that font bigger instead.
yep, absolutely. Options, configure.
Thank you.
I just always have to remember to shrink it. Otherwise, when I'm working on my
Oh, yeah.
deal with the house, it's a little hard. That big enough? Cool. All right. So we're going to create the grocery list. And let's do a simple little program where we have groceries equals an empty list. All right. While true, print, enter a item to add to the list. All right. Then we want to get this grocery item. So let's do that. And then we want to add that up to our grocery list. So one thing we should probably do is make sure we don't already have that item in the grocery list. So it would be something like if item in groceries. All right. Then we could just say print item is already added to the list. Else, now we want to add that to the list. How do we go about that? There you go. We use a pin, right? So we could say groceries dot append, and we're going to append whatever item they tapped in. And we could say print print item plus has been added to the list. Okay. And we could say something like this just to make this cute little program work a little better. Press enter to end. Right. And all that does is let us check to see if it's empty right off the bat. So we would say if item equals empty string, then we can break out of this. Let's change this to an elif and kind of move down. And then once we've broken out of it, we can go ahead and print everything in our groceries list. So for item in groceries, print item. And then for that, let's do this. Print, here is your final grocery list. Like that. Okay, super simple program. All we're doing is collecting all the groceries they want to get. We're going to store it inside this list. If it's already in the list, we have a check to make sure that we do not add that one. If they press just enter to end, it will kick us out, and then we print out the final list. So let's run this. We'll call this okay. So it says, what do we want to add to the list? Let's say towels. Let's say butter, eggs, and everybody loves spam. Press enter, and we can see our program. I can get it to move correctly here. And went ahead and printed out our final grocery list and then put them out in a nice little display, right? Well, what happens if I want to order like 10 towels and 2 sticks of butter or 3 dozen eggs, right? My list doesn't allow me to do that. It just puts a grocery list on there. So if any of you are ever married, you're probably told that you need to go get specific numbers of something. Don't just come home with random numbers. At least that's the way it works in my house over a few. So to fix that, we should probably use some dictionaries. And that allows us to set 2 different values of each one. We can give the key of whatever that is, and then the number of those that we want to return, right? The benefit to this list is we could actually sort it alphabetically if we wanted to, right? So we could come through here and we could sort it before we get here. We could say groceries dot sort, right? Does anybody remember that will sort it alphabetically, right? So that makes it a little easier for us to find it. Let's just save it, run the same program real quick. So eggs, butter, toast. Can't buy toast, but we're going to try it. And you can see it's automatically going to sort it inside of there. We did eggs first. It's now going to be in the second item and toast. Has anybody done grocery shopping? Does an alphabetical list help you at all? No, right? What would be beneficial? Location, like an aisle. Well, that's an aisle 10, aisle 12, etc., right? More information you give them, the better chance the husband comes back with the right item. Okay. We all have Walmart on our phones or whatever. We can see exactly what aisle it's in now, right? So let's build something that would be more beneficial for them to go out and do that. I'm going to blame this because I'm a husband and I mess it up all the time. All right. So we're going to take this and just comment this out for now. So with a dictionary, let's go ahead and do our groceries again. And we're going to have one dictionary inside of there. Now, we can format this a couple different ways, but we also know a quantity that we want, and we wanted to add a location. Is there anything else about that particular grocery that we might want? Yeah. What's that? Brand, right? Yeah. That way they make sure they get the name one. We want Sara Lee. We don't want the off brand, right? The boys like our toast, and we like it with Sara Lee. So let's make sure we set a brand in there as well. So let's start with this similar while true loop. I'm just going to grab a similar code here. We're just going to tweak it to be in our new section here. So let me take this, uncomment this out. Whoop, too far. Comment. There we go. So we want to add an item to the list, and then we're going to press enter. We're going to bring that in. Now, if that item is enter, we're going to go ahead and break. We're going to keep that functionality. If that item is in groceries. Now, what that item's going to do is it's going to look up the keys and see if it's in the keys. So this functionality still works. We can keep that. Else, we need to get more information about this particular item before we go and add it to our dictionary. So let's space this down a little bit. And we can do a print. What brand do you want? Okay. And then let's get that input. So brand equals input. We could do another one for print. What is the location? And location equals input. Okay. And the last part was quantity, right? Okay. So now what we want to do is we want to add to a dictionary. And does anybody remember how we add to a dictionary? Append is for a list, right? That's what we did here in the old one. To add to a dictionary, we just say groceries, the name of our dictionary. And then we set whatever key that we want inside that dictionary. So this is going to be our what? Yep. What is the key that we want to set in this case?
And
The item, right? So we want to set our item, and then we're going to create a dictionary of information that we're going to store for that item. The first one is going to be the brand. And we're going to set that equal to our brand that we typed in up above. And then we could do our location. And then our quantity down here as well. And so we would go ahead and end our bracket there. Okay. So this is what a dictionary looks like as a whole. We would have a dictionary that has a key of brand. And now this is the string brand. This brand is going to be whatever they typed in up above here. So all we have to do is look up brand, and it returns Sara Lee or Kroger or whatever they decide to type in. Location will give us back something in quantity. Right now, all of these are going to be what? Because they typed them in. What data type? Strings, right? They're all coming in from inputs. So if we wanted to convert this quantity over to an integer, we would have to test and do all that. For this purpose, we're just going to leave it as strings. All right. So once this is done, we can say this item has been added to the list. And then at the end here, we need a nice clean way to print this out. For now, I'm just going to have you print out the entire dictionary. So let's just print groceries for now. And then let's run our little program and see what this looks like. So similar format, we're going to enter in an item, eggs. Now it wants to know what brand we want. Well, let's just go with Kroger brand. If I can spell. All right, what's the location? Those are in A1. How many should we buy? 36, right? 3 dozen. Eggs has been added to the list. Now we're going to enter in a new one. Now we should probably add some spacing in here and make it look a little better, but it works as it is. What else should we buy? Well, we know we got to have our bread, and we know we're doing Sara Lee. All right. Anybody know what aisle that's in? L2. Sounds good. How many are we buying? 1 loaf of bread. 4 loaves of bread. Ain't nobody buying 1 loaf of bread. All right. What else should we add in here? Cereal. Okay. What brand? It's a test.
Magic spoon.
Magic spoon. All right. We got the health guy over here. It's not bad though. I actually like Magic Spoon. And which location?
C2.
C2. All right. How many boxes we buying? Oh, you're rich. All right. We hit enter. This is our outside dictionary. Now notice that is super hard to read, right? So what we would want to do is pretty print this out so that we could see this nice and clean going through here. But if we take this out and we go back to our program, I'm just going to copy what the output of that was. And we paste it in here. You'll notice again, it runs off the screen, right? So let's go clear back to the left. Okay. We have our original item of eggs, and then we have the brand of Kroger, location A1, quantity 36, right? So we can bring this down so we can see it a little bit. And all I have to do is click right before that key, press enter. It's automatically going to organize it for us. On this, if I press enter before bread, it automatically brings it over to our items. So these are going to be our keys. The value is this entire dictionary. And inside that dictionary, we have a key of brand and a value of Kroger. Location A1. All right. So let's do this one. Whoops. Wrong stop. That's not the one. Undo. There we go. Should be here. Quantity. And our cereal. Location. Quantity. Enter. So that's what it would look like if it's nice and formatted cleanly. We can do that by simply coming back up to the top of our project, import PP print, come down here at the bottom, and here where we're going to print it, we will use ppprint.ppprint. Okay. Once this is done, we can go ahead and rerun our project, and I'll just quickly enter in this information one more time. Actually, I'm going to cheat. And what we're going to do is take this dictionary as a whole and now make that our groceries up here. And what that does is make it to where I don't have to retype all that in. We're just going to test our project down here. Delete this out of here. What's that? We'll leave the inputs in there. What this does is just give us a starting list to go from, so I don't have to type it all back in. But we have this item. We can add one more item. Let's do like milk, and we could put in dairy fresh. Sounds good. R3, R4, because my fingers don't work. And we're going to buy 2 gallons. Milk's in there. We hit enter. Notice how Pretty Print did it nice and clean for us to come out. Now, it's not going to organize the second formatted list, right? But it at least gives us a nice clean output that we can go through and check. So super simple project, but it demonstrates the difference between a list and a dictionary. A dictionary allows you to have much more information as you go through so that you can store more attributes to that particular thing. Yeah.
Is there a way you could output that result to its own text file? Like, say, once you close the program, like that would all be deleted. Like, say you wanted to like send that, if your wife entered the list,
yep,
and then send to you. How can you have that output to its own file that stays there?
So that's in an upcoming week. But the answer is yes, you can do that. There's a couple different ways that you could do it. We'll cover it in those sections. You can output it to a text file. You could output it as a dictionary that you're actually storing, a Python dictionary, or you can kind of output it to a quasi database. There's a couple different ways to do that, and we will learn that.
Can you do it CSV?
You could do a CSV as well,
What's a CSV?
comma separated value, kind of like an Excel sheet. You could kind of do that kind of thing as well. You would just have to use other tools to bring it in, bring it out, do all that kind of stuff.
It just puts it in the table like the right way.
And then there's a module that you guys can use to actually work straight with Excel sheets too. Yeah.
We use the array list in order to have a better printing, like using rows and columns.
I'm sorry.
And we use the array list to recognize the printing. So
The array list? Is that what you said? You said the array list?
Yeah, like as you showed the chest game.
Yeah.
We could also choose the row and the column if you want everything to be in there. So we could use that in order to have the printing here.
You could, yes, absolutely. So for example, if we wanted to pretty print this inner list, we could do that as well. So to change that, we could come in here. And instead of just dumping the whole dictionary, we could say for K, comma, V in groceries. Remember, all that's doing is assigning the keys to the value of K and all the values, which in this case is that inner dictionary, to a value of V. So then we could say print K, right? So K is going to be our item. We'll learn a better way of doing this here in a little bit, but for now, this will do it. So for now, we're just going to print that item name with a colon. And then below that, we want to go ahead and just pretty print. And we'll pretty print V, which is that entire dictionary of the inside stuff. So let's see what that looks like. Again, pretty print is really useful for debugging. It's not great for, oops. Yeah, I broke that. It's because I hit the wrong button there. Too many values to unpack. Expected 2 values. Groceries. Let's look at groceries. That should totally work, by the way. Oh, what am I missing here? That's not making it work. I do this all the time. What's that? In groceries, right? This is the line that actually has a problem. If I just say groceries, what am I getting back? Not a dictionary, but what is actually going to come back if I call in groceries? I'm just going to get back the keys. All right. So what this is looking for is just the keys. Well, that's only one value to unpack, not 2. So what I'm missing is my method of dot items. That will give me back the tuple so that I can assign K to the keys and V to the values. And I do this all the time on purpose. All right, so we'll run that. There we go. And so now it prints out our item with the colon, and then pretty print, because it's so short, it doesn't actually wrap it around. But if we had a lot more values in there, at some point it would say, okay, let's go ahead and wrap it. At the end, we don't ever want to print it out in that format anyway, right? We would want to print that in a much better fashion. So for each one of those, we're going to now say for A comma B, just for the lack of variables, in V dot items, which is now going to go through each one of the ones inside of there. Now we can print our A, which is going to be the name of whatever it is, location, brand, whatever else. So we're going to say A plus a colon. And for now, we're just going to give a space plus, I forgot my plus back here. Sorry. There we go. And we'll just plug in the value, which in this case, we put B. All right. And it's going to print each one of those as it goes down. And then it will start this list over. So in the end, what that little section will do is make it look a little more like this. All right. And to clean that up a little bit, we could give it some spacing so that it looks better. So once it's done with that entire row, we would go ahead and just run an empty print. And that will give us a list that looks like that. All make sense? So this is great, but do we want to go to A1, then go all the way to C2, then go to L2, right? So we would probably want to sort this out a little bit. And what we could do is we would pull the locations, in this case, all of those. We would want to sort that so that it gives us A, C, L. And then from there, we have to go back and look up what those values were. And that's where it gets a little tricky. And we're going to do that with the Ford experiment, because we can't just go look up the location and try to figure that back up to the bread, right? There's no way to know the value and be able to look that back up the other way. We have to go sort those. So, all right.
Can you put your code at the top of it?
Yeah.
Oh, that's what- okay.
Now, to make this look even better, which again, we could figure out a way to do that, but I'm just going to do this. If I do a /T in here with a plus, that's going to tab everything over once. And we're going to learn how to do that, but I'm just going to do it just so you see what that looks like. It kind of makes it look a little better as it tabs through there. So. Cool. I think I'm going to rebuild the Ford project with groceries now. I like that. I like it. So just as a preview, so you guys can see what we're doing with dictionaries and what that would end up looking like, I'll show you what the Ford project looks like. And again, we're not going to do that till next week, actually, is when you guys will do the Ford project. And so the Ford project is basically, I have this table of data. I'm going to end up making that a dictionary where the name is the key, the value is car, right? That's the name of a car. Then the year introduced would be a key, the value would be 1996. Production is 2014. Generation is third. Vehicle information, here it is. This whole line is one value of a dictionary, right? So we would say car 1 equals parentheses this stuff. Car 2, this one. 3, this one. Then once we get all those together, we'll put that in one big dictionary so that we can sort and do some stuff. That's actually what the homework assignment is. You'll have to write functions that just return things. Then you're going to write print statements based off the stuff that you wrote in. But we'll go through all this during that time. It'll all be next week. The reason that we're doing it next week is next week we talk about manipulating strings. That's where we can do the /tabs, where we can do print formats and actually print it out so that we don't have to concatenate 4 things together. It's getting kind of messy, right? So like here, in order to get that special line, I had to take this, concatenate the A, concatenate the space, concatenate the plus, and then the B again. We'll do a print formatted where we just plug in things where we want and just format it the way we would want it to look. It's much, much easier. And that's what you guys would do from here on out. Unfortunately, you got to walk before we run. All right. Anybody have any questions on dictionaries? Practice with them, play with them, see if you can do the tic-tac-toe project, right? So come back up, follow the steps through this tic-tac-toe project, see if you can come up with the answers. And if you look, you can actually go get the source code for it and kind of compare what they gave you as an answer compared to what you came up with. I promise you, if you do this, the Ford project's going to make a whole lot more sense, because the concept, instead of you saying top left, top right, it's the Ford car, 1996 generation, blah. It's the same thing. You're just pulling out more data out of each piece. It'll also be a whole lot easier for your midterm projects and your final projects, because you guys will understand lists and dictionaries, because you must use one or the other at least in your midterm and final projects. You have to have examples of a list and examples of a dictionary. All right. Anybody have any questions? So I'm going to stop the recording.